Hey there, welcome to this video. In this video today, we'll be building a Spring Boot web service using the latest version of Spring Boot, version 3, and Java 17. In this video, we'll use Mapstruct. We'll be using Lombok, and we'll also be using tools such as Postgres database, Spring Data JDBC, and also Postman. We'll use Docker plus Docker Compose. So this video is going to have a lot of useful information for you. So without further ado, let's jump right into it. Alright, we'll start by initializing a new Spring Boot application, and the easiest way I believe to do it is to head over to this website, start.spring.io, and you'll be presented with this page. Once on this page, you go ahead and configure your project. I will be using Gradle for this project. You can go ahead and use Maven if you want, and also we'll be using Java. Now, I will go with the default version 3 of Spring Boot, which is 3.0.6. There are some RC candidates, but we don't want to work with those. And for the project metadata, we just set our group ID, and I'll set ours to io.onDev. And then our artifact, I'm just going to call it recipe API. Let's say recipe service. So this application is going to be like basically managing recipes for our clients. Okay, so I will just give it some description. Manages recipes. Hope I'm spelling it correctly. Okay, recipes. Now, for our packaging, we'll go with the jar, and for the Java version, we'll use Java version 17. Now let's add a few dependencies in our project. We'll start by adding the Spring Web dependency, and also we'll add the Spring Data JDBC. This one, we're not going to use JPA, we'll use Spring Data JDBC, and we'll add what else do we need? The driver for Postgres. We'll add Postgres SQL driver, and all right, we'll start with this for now, and then we'll add the others later as we go along the build. Well, once you've configured your project like so, you just go ahead and hit this generate button, and it's gonna download it into your download folder. Next, I will show you how to bring the project into your favorite IDE. We'll be using IntelliJ for that one, so let's go. Before we start creating our packages, I want to make a small change inside of the project resource folder. I want to change the extension of this file to application.yaml instead of application.properties. So I will right click on it like so and select refactor, rename, and change this part to YML. The YAML syntax is more convenient, so we will use that in this project. I'll come back to this file later. Now let's go ahead and create our packages. Firstly, we'll create our not a class, but sorry, a package like so, and this is going to be our domains package, and then we'll create another package called the web, another package services, another package called DTOs, and another package called repositories. We may create other packages later as we need them. For now, these ones are okay. Next, we're going to start creating our entities and start writing some codes. But before we do that, we want to introduce Lombok and Mapstruct in the project. So we will do that next. So Lombok and Mapstruct are Java libraries that simplifies the life of a Java developer by taking away most of the pain associated with developing Java applications. They are both code generators, and the way they do generate the code tend to conflict with each other, especially when they're used in the same project. So there's a technique to allow them to work together and understand each other without conflicting. I'm going to open up my builder Gradle file here, and let's see our dependencies that we have already. um, Basically we just have a nice Gradle, and inside of this Gradle file we're going to add a few more lines of code to add the Lombok and Mapstruct dependencies. I've already set them up in another file here to reduce typing, so I'm just going to copy them over and then I'll explain to you. So I'll copy this first line, Command C, and then bring it over to our project here and paste it like so. So this is simply defining the versions of our project. So if you are using Maven, for example, this is like saying setting the project version, like just setting versions, you know. And next, I will copy the implementation, and then I would paste it here. So this is the implementation for Mapstruct and implementation for Lombok. Next we'll bring in the processors, the annotation processors. And next I'll put that here. I tend to like separate these to be organized. Now our annotation processors are here. Next I will add this one. I like to call it the resolver. So basically we've added a Mapstruct with this version, and then we put the version in a variable like so that we can use it in multiple places without typing the version, you know, over and over. Same thing we did for these ones. And we added the implementation for Mapstruct and then the implementation for Lombok because this is a greater project. Next we added the annotation processors both for Lombok and Mapstruct. And finally we added also this annotation processor for the resolver, like it's the one that allowed the both of them to work together easily without having problem. And this is a really decent project because it take away all that conflict that Mapstruct and Lombok, you know, used to have with each other. One more thing I want to add is the test annotation. This is if you're using the Mapstruct within your test, is necessary that you add this annotation processor so that Mapstruct can work within your test codes and all of that. So that is it for Mapstruct. All we're gonna do now is to reload our Gradle file and hope everything works fine. Awesome. Now that we have Lombok and Mapstruct within our project, we'll go ahead now and start creating our classes. All right. Now we're looking good to start writing some code. Let's start by defining our domains. And to do that, I'll create our aggregate root, which is our main domain, and I'm gonna call it recipe. The idea of having aggregate and aggregate root in domain-driven design is that you have the aggregate is a collection of um, entities, and these entities are grouped together inside like a cluster, and there's one entity, the main entity or the aggregate root, that is going to be the one to manage all of their life cycle and everything. So when you're saving into the database, you're saving them all together as a group, and when you're retrieving them from the database, you're retrieving them all together as a group. When you delete them, they're all going to be deleted as a group. So for instance, in our recipe is going to be the aggregate root, and then we'll have another domain also, which is going to be the ingredients. Since our every recipe needs a list of ingredients, and if we delete the recipe, we will also want to delete the list of ingredients associated with it. That's why we're going to have the relationship between them like that. So let's define first of all our recipe. First we'll define the ID. I will use UID, recipe ID, like so. And then let's define the recipe name. And then let's define recipe description, for example. And also we need to add a list of ingredients. I'll call it ingredients list, like so. All right. Before we proceed, I will firstly go ahead and create this. Why my list is like this? Okay, good. Java util list. It's okay. All right. Let's go ahead now and create this class. So create the second domain domain entity, and Java class. And for this one, I'll be using Java record since I just wanted to store some values. Okay, so I'll be using Java record, and we're gonna call it ingredient, like so. And the ingredient have two properties. It's gonna have a string type called the name of the ingredient. It's okay, and the quantity. The quantity will be of type integer. Okay, this is good. And now we can import this, and we can also import our class. I don't know why I removed it first, but it's okay. Well, with this now we can go ahead and start using Lombok to do some auto generation of code for us. So firstly, we'll start by um, defining the all args constructor. This will create the constructor with all arguments inside of it, and we use also the no args constructor. This one will give us an empty constructor, and then we'll also use the a builder annotation. This one is can help us create the use the builder pattern, uh, and I'll add the data annotation for getters and setters. And finally, I need to define the table annotation. Remember, this is coming from Spring Data relational, and this is to define the name of the table within our database. So I will do auto import, and then give it a name, recipes. By the way, if your table name is the same as the name of your entity, you don't need to really put this table annotation here, because the framework will do the auto mapping for you. But if your table name is different, and that way you need to specify the name of the table so the framework can know how to do the mapping. Okay, so for me, I'm using the plural form here, and so I like to have the table annotation, that way I can be sure of my table names. And also, for this to work, we need to add the @id annotation here to specify our primary key. Awesome. So this is looking good. Next is this part. We need to tell the framework how to relate these two, because this is coming from another place. How to to create a relationship between this one, this ingredient, and the recipe. So the way to do that with Spring Data JDBC is you use the annotation called at map collection, the first one there. And inside this at map collection, you need to specify two things. You need to specify the ID column, which um, and then you need to specify the key column. So for this tutorial, I will just use the ID column would be the recipe ID. That is the ID column of the recipe within your database. And then for the key column, I will also use the same thing. So that just to keep it simple, I will use the recipe ID as well. Okay, so now this is looking great. One more thing I will add is the Lombok builder annotation default implementation for this builder.default. I think it's like this. No, not from Mapstruct, but it should be from Lombok builder.default. Alright, this one. So builder.default, I'm gonna tell it how to build this list when nothing is provided to it. So I'm just gonna tell it to use a new array list of ingredients, like so. I'm going to import this one. So now this is just telling builder when we are using the builder pattern to create an empty list instead of maybe getting confused or using unknown. So just create an empty list for us. Awesome. Now we are looking good with this one, and we are also looking good with this one. Yeah, one more thing here, we need to specify the name of the table here as well. And I will call it ingredients, like so. Nice. So we have our domain layer setup. Now we have our root aggregate, and then we have our dependent aggregate here. So they are all well interconnected. And so we will move on now to the next layer, which is our, let's move on to our service layer. Okay, so in our service layer, we are going to start by creating an interface, new interface, Java class of type interface, and we'll call it recipe service. So inside of this interface, we will declare all of the actions that we want to perform on our recipe. Okay, so in this project, we imagine that our client wants to be able to save or create new recipes. They want to be able to list all of their recipes and see them. They want to be able to uh, query a recipe by its ID to get one recipe, specific recipe. And also we imagine that they want to be able to edit their recipe, and they want to be able to delete the recipe. So we know these add actions. So basically it's a CRUD operation. So let's start by implementing that. We'll firstly define um, we'll declare the method to save a recipe. So for this, we'll be returning a string and call it save recipe. And remember, there's an interface, so we're only declaring the method. We write the method signature, not the implementation or the body of the method. So to save a recipe, we need some payload. So we're going to put that inside of a DTO, and we'll call it save recipe request. DTO, just to be more clear about it. And then and then we just got a save recipe request DTO, save recipe request DTO, like so. And remember, this is not yet defined. We'll define it very soon. So let's go ahead and do the other ones. We want to save recipe. We want to update recipe, and then okay, we want to update recipe. So I'll just go with this. By the way, this auto completion here is powered by tab 9. Tab 9 is a really useful AI code completion tool. When you have IntelliJ, you can add it to your list of extension or plugins. I don't know. So next, we will need to be able to list our recipes. So recipe DTO, and I've just got to get our recipes, like so. And this one will take no argument because it's getting us for us all the recipes in the application. And then the next one is to get a single recipe. So get recipe by maybe the name of the recipe. So it's going to be a string. Okay, and okay, this is good. So now we have this, or maybe we can say get recipe by the ID, which is more practical. String get recipe by ID, and then we need the recipe ID, like so. And I think the last one we need is the delete one. So I'll just return a string. give us a message that this recipe has been deleted successfully or not. So go ahead and write the delete recipe. I'll just go by ID there, and we'll take the recipe ID as well. Awesome. So now let's go ahead and define, create all these TTOs. So I'll start by creating this one first, and I'll come inside my TTO package here and create a new Java class of type record, because TTOs are just like transfer objects, so we use records for those. Awesome. So now what is this guy going to be transferring first? And for that, I will just open my recipe class here side by side to see the properties that I want to send when I want to create a recipe. So to create a recipe, I don't need to send the ID, because the ID is going to be generated automatically on our database. And then for the recipe name, I'll need that. So I'll need the recipe name. The client needs to send me the recipe name. They need to send me the recipe description, and they also need to send me the list of ingredients associated with that recipe. So the list of ingredients. Okay, so let me import this list, and it's gonna be called ingredient. No, it's ingredient list. Awesome. Great. So with Java records, you don't need to do anything extra. You just define a record like so, and then pass in the properties that you need, and that's it. It's going to seed it for you with finals, and it's immutable by default, so it's great for transferring data between two components also. Alright, so we have our recipe, save recipe request CTO. Now let's go ahead and create the other one. Let's open our service and import this one first. Input class. Now let's create this one, the update. I'll copy it, the name, and create a new Java class of type interface, not interface but record, and paste it like so. So for the same thing, to update a recipe, we need to have similar to, I will create some room here, similar to the save recipe. Let me just bring it on the side, and similar to this, we need to send in the same information plus one more. We need to send in the ID of the recipe as well, so we need to send in a string. The ID is of type UUID, so we can map that like that. UUID, recipe ID. Okay. By the way, I can reference that from here because we use UUID. Okay. Now that we have our updated request GTO, we can now go ahead and create the next one. This one is the recipe DTO, that is the recipe data itself. So for that, I'm gonna do the same thing, create a new Java class using Java records, give it the same name, and pass it back the information that I need. So basically, I need this information. Okay. Awesome. So now we are good here. I'll just close all these ones like so, and so. I'll close this one as well. So import this and import this one. Nice. Now we have declared our interface and declared all the methods that we need here. We now need to write an implementation of this interface. So let's go ahead and do that next. Now to implement this method, what we'll do is we first all need to check the database if there's a recipe with this ID. So if there's a recipe, we need to return that recipe but if there's no recipe with that ID, we need to throw an exception. So to do that, I will call the recipe repository, like so. We've already injected it here using the constructor injection with the help of the require axe constructor here. So we do the recipe repository dot find by ID is a method that is already defined on the repository, and then we'll pass in our ID from string, UUID from string. Remember, our ID is a UUID, but the ID is coming from our client is of type string, so I need to convert it using this technique right here. So I'll just pass in my recipe ID like so, and what this method returns is an optional, so that means I can check on it and do further things, like for example I can do this OS throw. So with this OS throw, if you have if we had implemented our own custom exception, we can throw that exception here, but we do not have that exception in this case, so we will go ahead and just use it like this. Okay, this one we don't need that, so we'll just leave it like this, so it will show a regular runtime exception. All right, now maybe in the future we'll look at how we can handle exceptions. So basically this is it for now. Next thing we need to do is to delete this recipe that we found, so we got to put it into a variable, so it's going to return to us a recipe. I'm going to get it saved recipe like so. All right, let's see if we can input. Okay, awesome. So this is going to return to our recipe if it is found, or throw an exception if there is no recipe. So once we have a recipe, we can go ahead and delete it like so. Recipe repository dot delete, and then we'll pass in the recipe, the saved recipe, this one. All right, so after that we can return a message saying successfully deleted recipe. Okay, awesome. Now that we've done with this one, we're done with delete. Let's go ahead and work implement the rest of the methods. Things are starting to get really interesting now. So let's go ahead and implement the get recipe by ID method. So this method is we're gonna do some code reuse here. So I'll just copy this code like so and bring it here, because we're gonna need to do the same thing. We need to find the recipe by the ID and see if it is existing. If not, we throw an exception. And if it is existing, bring the recipe here. So now this recipe, we'll have to return it. But note that the return type of this method is a recipe DTO. Okay, so imagine the situation that you have to abstract certain values away from your client, and let's say you have an entity that stores values for your client. These values are sensitive to a certain degree that you don't want to expose them. For example, credit card information, password, date of birth, some sensitive information. So in order to keep those information away from the reach of clients that will be communicating with your API, you create something like a DTO with only the fields necessary for that maybe method call, that API call. So for example, here in recipe DTO, we have some fields that we've defined here: recipe ID, recipe name, and recipe description. Let's say we don't want to send the recipe name, we can remove it and we will not send the recipe name, only the recipe ID or the recipe description, and the ingredient will be sent back. But this is just a simple example. Now the idea here is, how can we convert this recipe type to this recipe DTO type? There are a lot of ways to do it, and Mapstruct is one of the fancier and easier way to do it. I think it's the most efficient way, in my opinion. There are other libraries too, like Orica Mapper, and you can even use the Beam YouTube. But with Mapstruct, you have further flexibilities. So we'll be using Mapstruct to implement that. So let's go ahead and get our Mapstruct configuration set up. So to work with Mapstruct, I will create a new package inside our project, and I'll call it Mappers. And inside of this Mappers package, I will define our recipe mapper, like so. So Mapstruct uses interfaces. So you describe your methods, and then Mapstruct will do the implementation for you automatically. So I'll call this one recipe mapper, and it's gonna be of that interface, like so. Okay, so remember when we created this interface here, we went ahead and created the implementation of it manually by ourselves. But with Mapstruct, we will create the interface like this and annotate it with at mapper. That way Mapstruct will know it's a mapper. And we also need to configure one more thing, the component model. This we need to tell the maps. If you hover already, you have more information about this. It specifies the component model to which the generated mapper should be adhered. So this will allow us to inject, do dependency injection with the interface. So we can do something like dependency injection. You can auto wire it or use constructor injection. So for us, it's Spring in this case, and this is should be double quotes, like so, and nice. So with this, I can now go ahead and define my mapper. So the first mapping method the first mapping I want to perform is, I want to perform a mapping from a recipe to a recipe DTO. Okay, so say recipe DTO. So say map to, I'll just call it map to recipe DTO. All right. So here in our argument, we'll take a recipe and we map it to a DTO, recipe DTO, like so. And that's all we need to do. Okay. Once you've done this, like so, and you have the annotation at mapper, and then you configure the component model, all of that, Mapstruct will automatically make an implementation of this interface with the actual code that will do the copy and paste. Like it's called a copy and paste. It's going to copy the properties from here inside of the recipe DTO. All right. So that way you will not have to do that by hand. So let's go here and try to use that. So first we need to inject our mapper. So I'll say recipe mapper, like so. So now when we come back to our stuff here, we can easily use the recipe mapper, like so. And then we call the method that will map our recipe DTO, map our recipe to recipe DTO. So we just need to pass in the recipe, and we'll pass in saved recipe, like so. So it's going to return to us this time. And that's it for this one. So Mapstruct went ahead, would go ahead and create for us the implementation of that method. Like we don't need to write the implementation like we are doing here. Okay, so let's go now and continue the implementation. Next is to get our recipe. To get our recipe is something similar. So we will get here we will not be checking if a recipe exists or not, because we want to get all recipes if they exist. If there's no recipe, just give us an empty list. So there's a method on the repository that will help us with that. So just going to get we'll get a list of recipes. Okay, like so. And I'm just going to get a recipe list, and we're going to get our recipe repository and call the find all method. this find all method will return to us everything that that is just inside of the database. By the way, this is returning for us an iterable, so I just need to cast it to this type, like so, and we should be good. Okay, so now that we have our recipe list, it could be empty, it could be a recipe list with values. All right, we need to return it, but remember that we are required to return a list of recipe detail, not a list of recipes. So we're gonna need the help of Mapstruct to help us do that bean mapping for us to convert our type. Okay, so let's go back to our recipe mapper here, and then we'll do the conversion. We need to convert to recipe to a list of recipe DTOs. Okay, I will import this, and I'll call it map to recipe DTO list. Okay, and what we need to pass in as argument is a list of recipes, like so. I'll call it recipe list. Awesome. That's all we need to do here, and when we come back to our implementation class, we just need to do the same logic, and we'll call a recipe mapper, like so, and then we pass in the list. All right, and just like that, Mapstruct will go ahead and map our list to this list here. Nice. All right, now we are getting there. Let's go ahead now implement the update recipe. For the update, we firstly need to find the recipe that we want to update. And to do that, I will come back here and reuse this code. I'll copy this one and paste it here. So now here we need to pass in our recipe ID. So I will get it from this object. Remember, this record has recipe ID there. So when you're asking us to update, you need to pass along the ID of the recipe to update. So I'll just get that recipe from that object and do it like so. Recipe ID. All right. So now we'll have our recipe here. So this recipe here, we need to update it with the value of the recipe of the new value that is coming from our client. This one. How am I going to do that? We need Mapstruct to help us do that for us. So we'll go back to our mapper and we will create a method that will return for us a recipe, and we'll call it update recipe. And this update recipe will take two arguments. It will take the source and the target. So for the target, we'll annotate it with let me do the source first. We are mapping from the source, which is update. This is the one that is having the new values, and the recipe is the one that we need to update. Okay. So this is the saved recipe. This is the one we have in our database, and this is the one that is bringing in the new value. Now we need to inform Mapstruct about this. We need to let them know where are we mapping from and where are we mapping to. The way to do that is by using the add mapping target annotation like this one, like this. So now we've instructed Mapstruct that when you are generating the implementation of this method, note that you are going to be mapping from this guy to this guy. So this recipe is a target. And finally, in the end, we want to return the update the recipe like this here, so that we can do some other stuff with it. So I'll save this and go back to our recipe service implementation and use that. So I will now go ahead and do I'll create a new recipe, and I'll call it updated recipe like this, and then I'll use my recipe mapper That will say update recipe and pass in the two values. I'll pass in firstly the source, which is the new value that are coming from the client, this ones. I'll pass it in, and then I'll also pass in the one that we already have in our database, the saved recipe, this one, like so. So now the result from this mapping will give us a brand new recipe with the latest value, this one, updated recipe. So all I need to do now is to save this new recipe. So I'll call my recipe repository like this, and then I'll save it. Okay, and I pass in the updated recipe. Now I can go ahead and return a message, recipe successfully updated, something like this. Okay, back to our client. Awesome. Now that we've done with this, let's go ahead now and do this one. And I guess we will need something similar. I'll just copy this first line here. And to save a recipe, we don't want to save a recipe with the same name in the database. So let's say there are two recipes having the same name, okay? So let's say we want to perform a check to know if there's a recipe already in the database with this name. To do that, I will let me just rewrite it instead of pasting. So create a boolean. So I'll just use the var keyword, and I'll call it is existing. Okay, so now I will go and call the recipe repository that find by, and I'll create our own method that will help us to find a recipe by the name. So it's find by recipe name, like so, and pass it a string. Pass it a string of type recipe name. So saved recipe request dot recipe name, and then I will let me create this method first in our repository. Now I will like for this to return for me an optional. That way I can optional of type recipe. That way I can do further chaining on it. Let's import. What's going on? Okay, all right, now let's import. Good. So Spring Data JDBC will automatically generate the query that will find a recipe by the recipe name, just like that. Okay, find by recipe name. So if I wish to write the query manually, I can use that query annotation and write the SQL query to do that. But I will just let the framework do it for me. I just need to have the syntax. That's it. Okay, so let me remove this. Awesome. Now I'm back in my service. Now because I'm returning an optional, this method is returning an optional, I can go ahead and do some checks. I can say if it's present, like so. So if this there's a recipe with the name that the client sent to us already exists, this would be true. But if there's nothing, it will be false. So now what I'll do is I'll perform a check like this. I'll say if it is existing, that we already have something, it should throw a new exception. Let's just throw a runtime exception. Recipe already exists. Okay, but normally what you would do is you have a custom exception that you would throw here and handle it somewhere. But for now, we'll just throw a runtime exception. But if it is not existing, that is, this is false, this line will not execute, so the exception will not be thrown, and we'll proceed. We will then go ahead and do the recipe repository dot save and save our recipe. But remember, our recipe is coming in a different type. It's coming in with this type, and we cannot save this type to our database. So we need to convert this type to a recipe type. So to do that, Mapstruct, you already know. So we come to Mapstruct and define a new, let me just do it right here at the top. We'll define Mapstruct mapping method that will convert our save request to a recipe. So say we want a recipe, and we'll say map to recipe, and we use not mapping target, we'll use save recipe request TTO, and save recipe request TTO like so, and then it will go ahead and return for us a recipe that we can save. So I'll save this and come here and I'll use it. I'll just say recipe mapper dot map to recipe and pass it. What are we mapping to recipe? We're mapping our request, the save request. Now, good. So I'm just going to put a semicolon and we will be fine. Just like that, we've saved a new recipe to our database, like so. So I'll just return a message to my client, recipe successfully saved, like so. All right, so we've completed the implementation of our service. Next, we will go ahead and do the controllers. Then after okay, for our service layer, we've completed all of the methods and implementations that we needed to do. So now let's go ahead and work on the web layer. So in the web layer, I'll create a class called recipe controller. Okay, and we will annotate it with at rest controller, and also with at request mapping, and give it a default route of /recipe. Okay, next I'll also add the Lombok at require args constructor, like so. Now first thing I will do here is I will inject my service layer inside of my controller. I'll do private final recipe service, and I'll call it service, like so. That way I can be able to use my services, all these methods that I've created and implemented, I'll be able to use them inside my controller easily. Now the first endpoint that we will create is the endpoint to list all of the recipes in the system. Okay, so for that we'll use a get mapping, and this get mapping will return for us a response entity that will send us back some object. I'm not going to specify the type, and I'll just call it list or recipe, and this recipe will return for us a response entity of the status code of OK, and the body will come from the service. So service dot get all recipes. Okay, now just like that, we've created our first endpoint. So when you go and send a get request to /recipe, you will be returned with a list of all the recipes we have in our system. All right, now let's do the other one for getting recipe by ID. So it's still going to be a get request, but this time we also need to send in the ID of the recipe as a path parameter, a path variable, and we'll also return a response entity. And then I'll specify the type, but I'll just keep it like this for now. I'll just say get recipe by ID, and then we'll need the ID, which is a path variable. This path variable has a name of ID, and it's going to be of type string recipe ID, like so. Now we're going to return similar thing as we did here. We want to return a response entity of OK, and then for the method that we'll call to get that is service.get recipe by ID, and then we'll pass in the ID here. Okay, now you are seeing how things are getting connected into each other. So we build the service layer, now we bring it into the controller, and we are just using this method that we created. Nice and simple. So you can see the difference layer and the abstractions here. building application like this make your code lean, easy to maintain over time. Now let's go ahead and do the one to save our new recipe. Okay, so to save, we'll normally send a post request. Okay, so we'll do a post mapping, and we'll send a post mapping to the base endpoint, and we will return a response entity as well. And click this, save recipe, and we need to pass as an argument here the payload. Okay, the data that we need to save, and we already have a DTO to hold that information for us. So we call it save recipe. What do we call it? Okay, first we need to annotate it with at request body, and then we'll convert it to the DTO, save recipe request DTO, like so. All right, so now I will just return response entity also, but I will not return .ok. Instead, I return .status and pass in another status. So when we create something on the server, normally we use the status code 201. So I just use HTTP status that created this one. Okay, so now that we have our status code, we can now pass in the body, and inside the body I'll call my service and call the method to save a recipe, like so, and pass in the recipe DTO. Once I do that, we are done with that API. Next API is to update. So for updating, we use the port request. So the equivalent here is port mapping, and we need to return something similar. So I'll just copy this code, and I will change a few things. I'll change the name. I'll just call it update recipe, and I'll just keep the same status, but the payload is different. We have another payload for that. It's update request DTO. So it's called it the same way, and I will change this one. So we are not saving now, we are updating. We have a method for that already. So we'll call the update recipe method and pass it this payload object. And just like that, we are good. So the next one is the delete. For the delete, I'll use delete mapping. And for this mapping, I'll use response entity like before, delete recipe, and we'll not use request body. Instead, we'll just need the ID, because only the ID we need. So we need a path variable. We'll call it ID. Something similar to this one. It's the same thing, not even similar. So I'll just copy. Let me just type it. I'll just type it like so. / and then the ID. Okay, so it's gonna be a string, and then we'll call the recipe ID. After that, I can return like so. So response entity status of OK service dot, the method is called the recipe by ID, and I can now pass in my ID. And I will add an exception handler here. I need to verify why it's asking me for exception handling. I will check the implementation. Okay, no problem. Maybe it's because of this exception that we threw in here. So let's just do that, and we should be good. Oh, we don't really need this exception. We're not throwing it anyway, so I will remove it and I will fix it from the service. Or extra. Okay, it's here. We're not showing this not bound exception anyway, so we don't need that. Awesome. Now we should be good. So we've implemented all of our APIs, and now we need to go ahead and complete the configuration in our project. We need to configure the data source, and also write the SQL schema for our database. So we will do that next. Okay, not to delay too much in this configuration, I've already copied and modified the code we need to write here. So I'll just bring it in and explain to you what it's happening. So basically, we've configured the application, give it a name, recipe service, and we've configured also the SQL init mode. That is, we'll say whenever the application starts, it should also initialize the SQL schema for us. We'll prepare the schema shortly, and also when we'll configure the data source and username, passing the username, the password, and the database connection string. In the database connection string, we've mentioned we added the database name. So our database is called recipe DB. We will create it also shortly, and we've also added the Java class name, specifying that we are using Postgres, and also set up Hikari to manage our connections. So this is basically all we need for our application.yaml. And for now, let's go ahead and create our SQL schema. So for that, we'll open within our class path and our resources folder, we'll create a new file called schema.sql. So inside here, we will define all of our tables. And I also don't want us to waste too much time on that, so I have it already here. I'll just copy it and walk through it with you. All right. So basically, what we're saying here is that we want to delete the table if it exists, and start it fresh. So we don't want to have the same table in the database whenever. It's similar to create drop when you use the JPA, but this is what happened here. We'll drop in the table if it exists, and then we can go ahead and create new ones. So we'll start it fresh. All right. So this is straight out SQL, plain old SQL. You look at it, what it's saying is create table, just like English, and then we'll give it some columns. These are the columns, the data type of the column, and I think the only thing that might be new here is this function. This is a Postgres database thing. It's used to generate UID randomly at the database level, which is very useful. And yeah, so similar things we have in our recipe entity. We just created the columns for them like so, using underscore instead of uppercase, like the camel cases. And the same thing for the ingredients table, we've done it like so. So basically we have also configure our application to always look in this resources file whenever you're starting. If there's a schema, execute the schema. That's what this instruction means. Next, we need to set up our database. So for that, we'll be using Docker Compose to run our database in a Docker container. So let's go ahead. I'll create a Docker Compose file from our project main root and create a file called docker-compose.yml. And here I have also I think it's here, this one. I will just copy it and bring it in like so. So this is a Docker Compose script. What it's saying is that we want a service, and in the service, we are defining a container, and that container will have a name of recipe Postgres, and then the image the container will run will be Postgres 14.4. And also we've configured the default ports and environment variable. So basically we just set the username and password. Also here I have added this volume. I've mapped this volume to the location in the current directory. This file here we'll write some script that we want to execute when the container starts. So basically this location inside of the Postgres container, Postgres normally looks there for any script that is there and execute it. So what we're doing is we are mapping that location to this location here in our project. So whenever we run the container with Docker Compose, it's going to automatically execute whatever script we have written in here. So in our use case, what we'll add there is I'll just first of all go ahead and create the file. It's called init.sql, and for us, all we need to do there is to create a database. Create database, and the name of the database will be, what is the name of the database again? Let me come back to my, I want to be sure, and this is the name of the database. All right, so we should be good. Yeah, I think this is not necessary. I'll just remove it. Okay, we should be good now. So now whenever we start our container with Docker Compose, it should automatically initialize the database for us. It will create a database for us with this name from the script that we've added. All right, so next we will launch up everything and see if it works. All right, now we have almost everything set up. Let's go ahead and first of all start our development environment. Um, so we're going to start our containers. With that, we'll be using Docker Compose. So I will start, and for this to work, you need to have Docker installed on your system. So if you don't have Docker installed, you will have to go ahead and download Docker and install it. That way you can go ahead and use the Docker file here and run your Postgres container. So the command to launch the container with Docker Compose is Docker Compose up, and I'll add a -t flag to run it in the background. Now when I hit this, it should go ahead and create my containers for me. So now I have my recipe Postgres container running, and then next next thing I need to do is, if you're using the ultimate version of IntelliJ, you should be able to find the database icon here on the right. All I need to do is I need to connect it and click here, connect to my database and Postgres. If you don't see Postgres, I just type Postgres, it should pop up. So remember when we were configuring our database, we set the username to user and the password to password. So we just need those two information to connect, user and password. So let me configure one more thing here. I will select my, if you can see already my database is showing here. I'll select it and refresh. So I need the public schema. So I'm going to apply that and select OK. And just like that, I should be connected to my database. Now, when I expand this column, I'll see that we have the default Postgres database here, and we have my database. And if you are not using the ultimate version of IntelliJ, you can use other DB clients, like maybe dbeaver or Postgres PG admin. You know, it's nice as well. It gives you a nice way to visualize things in your database. But I'm using just the embedded one in IntelliJ, which is, you know, flexible. So why okay, and now I want to see my databases. I have my public schema. Let me go back here and configure one or two things. Properties, schemas, open this public schema, and let me refresh. Okay, that's my tables. Okay, it's right. My bad. I have not yet created any table, so we just have access to the public schema. So this is just a connection to our database. Happens sometimes, you know. All right. So now to be able to create our database, we've instructed our Spring Boot application that on startup, it should execute this script. So it should execute, not the script, but with this command, will tell it to execute the script that we have in our source folder, main, resources, and schema.sql. And this is the the place we have defined the DDL for creating our database tables. So let's go ahead now and try to start our application. I will click here to start it, and let's hope all goes well. Awesome, that was quick. So as you can see, let's go up a little bit. Our application started, and it went through this, initiated Tomcat, we put 8080, started the service, initialized the beta server, it went ahead, it did this connection, it grabbed the connection from the database, and all of the good stuff. So clearly we can see that it took about 1 second, 84 something to get started. So our application is up and running. Awesome. Now, I've also created a few endpoints just to represent the endpoints that we have here to prepare things quickly. So remember we have these controller with these endpoints that we define. Let's go ahead and test them. So to create a recipe, normally we need to send in some data. So we need to send in the recipe name, the recipe description, recipe image URL. This we don't need to send. This from another application. Okay, so we just send this information and then the list of ingredients. So by the way, in Postman, to send a payload, normally you come to body and then you select the raw type and choose the format you want. For our case, it's JSON. So now that we have our payload set up, we can execute a request. We can send a request to the system. Okay, remember our system is running on localhost 8080 and the endpoint that I want to connect to is /recipe. So when I send this request, it should return to me a recipe successfully saved. Awesome. Now we can verify by either checking in our database to be sure that a recipe was created, or we can send a GET request to see if we actually have a recipe. So I will do the latter. I'm going to send a GET request to get all of our recipes. So I'm going to send this one and we should get a recipe. I'll check here. Okay. So if you look, I will send this GET request again. You notice that we have our recipe coming back to us. So we have a list of recipes. Okay, in this instance we have just one recipe in the database. That's why we have it here, and you can see the ID of the recipe that was generated for us by the Postgres DB server. And we have our recipe name, cornbread, and then recipe description. And you can see the ingredients also coming out with it. All right, let's verify now in the database if this is actually there. So I'm going to click on my database, open and refresh. Remember when we came here first, we saw nothing. Not the Postgres rather, but this one. Now we have our tables. Before when we came here, there was nothing. So now we have our tables. And when I click here, I'll see that my 2 tables were created. So let's see whether they have data inside of this table. So we'll start with the recipes first. I will click here to see. And yes, of course, we have data inside of our database with the ID, the recipe name, the recipe description, and all of the good things. So this is working as expected. Now let's see the ingredients table. And now we're going to click on edit data, and graciously working. You can see that we have 2 ingredients and our ingredients are there correctly, and the recipe they're associated to, you can see the ID of the recipe here, and that's it. Nice, everything is working fine. Now let's go ahead and test the other endpoints. Let's test the edit recipe endpoint. So to edit the recipe, you need the ID of the recipe. So I'm going to copy this and come over to this request put, and I'm gonna send an edit request with this ID. So remember, our ID, our recipe name before was cornbread. One was just cornbread. Remember, it's just cornbread. But now we're going to modify it. So cornbread 2, and also delicious cornbread 2, and then we add the ingredients with the corn flour, and then we change the sugar to eggs. All right. So now let's send this request and see if it works. Awesome. We get our response back. Recipe successfully updated. So now let's verify if this worked for real. So we're going to send the next request, which is find recipe by ID. We'll send the ID here. Remember this endpoint. Find recipe by ID. Get recipe by ID. That's what we're going to test right now. So we're going to send the recipe and then the ID, and we'll see if we receive that recipe. And voila, we have our recipe here. And we have the updated recipe. See that? Now we can see cornbread 2, and then delicious cornbread 2, and that's it. Now let's test the delete endpoint to be sure that it's working as well. And it works like this as well. We just need to pass the ID of the recipe, and we send it. Now we have deleted the recipe. If we come back here and do a send request, we should have nothing. We have an empty list. So let's also verify that this recipe is deleted in our database. So we will come to our database and refresh. We should see that there's nothing there anymore. The recipe has been deleted. Also, for the ingredients associated with that recipe, if you refresh, they should not be there because of the domain-driven design. The recipe and the ingredient are part of an aggregate, and the aggregate root is the recipe. So if the recipe goes, everything in that aggregate is out. So everything is working as expected, and yes. And that's it, people. Just like that, we've come to the end of this video tutorial. I hope you find some value in it, and if you do, kindly subscribe and share the video with your friends and family and colleagues and whoever needs to see something like that. So until next time, happy coding.